My name is John van der Eerden. I'm the Vice President of Water Resources here at Associated Engineering. And in that role, I'm responsible for assisting and providing advice to our water resources practices across the country. A lot of the work Associated Engineering does is related to infrastructure. When we look at infrastructure, we most often want to produce sustainable designs. And infrastructure, by its very nature, has some form of impact on the environment. We want to make sure that those impacts are minimized, that they're mitigated to the degree possible, and if we can't fully mitigate the impacts, we look at how we can compensate and provide an ultimately sustainable design. The whole approach to managing stormwater has changed through the decades. If we go back to maybe the 1970s, we really dealt with drainage. We looked at ways to get the water off the land as quickly as possible, and the water was considered a nuisance. But as we moved into the 1980s, 1990s, and post-2000, there's been a real progression towards, first of all, managing stormwater, then treating stormwater as a resource. And I'd say more recently, it's really looking at the environment values of green space in a more holistic manner. Rather than putting a larger, more costly pipe in the ground, maybe it's money better spent to retain a park or a wetland that can provide that function of storing and infiltrating water. Much of the lower mainland is protected by a dike system. Many of the dike alignments that were constructed throughout the 60s, 70s, and 80s were constructed to sort of maximize the land available behind the dikes without as much consideration to give the river room and to provide the riparian habitat. And what that did is prevented the periodic inundation and flooding of those near river areas. So there's real significant environmental benefits to that sort of flushing that used to occur. It filters out sediments, it provides potential increase in aeration, it provides habitat for fish and amphibians, and also the ability of the river to convey high flows and flood. So there is a bit of a trend. There's certainly a desire to set back some dikes to make more room for the river, to provide higher and improved ecological values. And there's some areas where that's been quite successful. For example, in Port Coquitlam, we were able to take an existing dike that was along the riverbank and set it back approximately 150 meters, I believe, from the riverbank to allow that intertidal flushing to occur once again in those tidal areas. One of the things that I think would be of real value to society is looking at more of risk-based design in terms of flood protection. Rather than setting a standard that means all areas are protected equally, it would make more sense to have the level of protection related to the consequences of failure. For example, should a golf course be protected to the same level of protection, say, as a downtown core? So one particular project, we didn't just look at the financial loss, we looked at the triple bottom line. So we looked at environmental, social, and economic loss that would occur without the dikes. What we found, not surprisingly, is that it makes sense to provide a much higher level of flood protection to highly developed areas, providing a much lower level of flood protection for areas that are lightly developed or maybe have other land uses, such as a golf course or something like that. There's other benefits as well, because if you think about allowing an area like a golf course to flood from time to time, the water storage that occurs in that area attenuates the flow, so it actually allows you to manage some of the water that's propagating downstream and flooding and damaging other areas. So using a risk-based approach to looking at flood protection makes a lot of sense.